So this is a capacitor relay oscillator, and so it consists of a capacitor. These are two capacitors put in parallel, each 1 millifarad to create a 2 millifarad capacitor, an LED, a resistor in order to limit the current going into the LED in order to not burn it out, and a relay and a power source. So how it works is when the relay is in its normally closed position, such as this diagram right here, the power source is going to be powering, giving power to the inductor and to the capacitor and charge them like this. So it's going to charge the capacitor and the inductor. And once the inductor is charged inside of the relay, it's going to flip the switch. And then the power source is no longer connected to the capacitor and inductor. So the LED will turn on because now it is connected to the capacitor and the inductor, and it's going to drain the power out of the capacitor, and eventually the power or the energy stored in the capacitor will be too low to power this inductor still, and the switch will flip back to its original position. Once it's in its original position, it will charge the capacitor again from the power source, and this cycle will repeat continuously, flickering the LED on and off using the relay capacitor oscillator. So this is the capacitor relay oscillator with the 2 millifarad capacitor. So it's two 1 millifarad connected in parallel. So you can see it's blinking pretty fast. It's given a 9-volt power supply, and this is the oscilloscope showing the charge and discharge cycle of the capacitor. This is a circuit with the 10 millifarad capacitor connected. As you can see, it's blinking significantly slower than with the 2 millifarad. We're using an input of 9 volts. This is the oscilloscope right